Okay, a single positive ion has a mass of 6.68 exponent negative 27 kilogram and charge 1.6 exponent negative 19 coulomb. The particle moves clockwise in a circular path of radius 3.25 cm with a speed of 1.5 exponent 4 meter per second. Determine the direction and strength of the magnetic field. Okay, I think these questions we've discussed before. Similar questions, okay, if we refer to the previous video, these questions, yeah, this one is last time it's almost the same question, just change a little bit. Last time is negative ion, okay, negative ion. This time is positive ion. All the values are the same, yeah, you can see all the values are the same. Okay, all the values are the same. This one is a single negative ion, move clockwise. Okay, move clockwise, circular path, determine direction and strength of magnetic field. Okay, single negative ion and clockwise. For this one, it is a positive ion, move clockwise. So the difference is just the sign of charge. This one is positive ions instead of negative ion. Okay, so it's still clockwise direction. Okay, we want to find the direction and strength of the magnetic field. Yeah, strength of the magnetic field. So okay, the steps will be the same as before. Okay, so I'm not going to discuss the steps to solve the question again. So the answer is this one lah. Yeah. Magnetic field is 0.0193 Tesla. Okay, so I can write that the answer over here. Okay, the magnetic field I got is 0.019 Tesla. That's the magnitude. Okay, that's the magnitude. Refer to the previous video. Okay, just the direction. This video I want to emphasize on the direction. So this is a positive ion instead of negative ion like last time. So okay, so what do you think will be the direction of magnetic field? Okay, let me draw it out below first. Let me draw it out. It is a positive ion. It is a positive ion. So I can say okay, so this is the positive ion. It moves clockwise. Okay, it moves clockwise. Okay, maybe over here. Okay, he moved clockwise. Okay, at first he moved to the right, and then in the magnetic field, it will move clockwise direction. So I draw the circular path first. The circular path. So okay, so now I want to determine direction of magnetic field. Direction of magnetic field. So what do you think? Is the magnetic field going into the page or going out of page? So how do you know? So you must use your right hand rule. Okay, use your right hand rule. So still remember, this one is talking about magnetic force. Okay, right hand rule. Okay, it is talking about the magnetic force. Okay, so for this talking about magnetic force for moving charge in magnetic field. Okay, why do we say this is a force for moving charge in magnetic field? Okay, so force for moving charge in the magnetic field. Yeah, so why is it force? Why is it force? Because this particle or this positive ion, it moves in a circular path. Why it moves in a circular path? Because it has centripetal force. Okay, it has centripetal force. I can say is a to this, because the center is over here, isn't it? It moves clockwise direction. Okay, this positive ion, he moved in clockwise direction. clockwise. So the centripetal force must towards the center of circle. This is the centripetal force must towards this is the center of circle. Okay, centripetal force towards the center, and who provide the centripetal force? It is the magnetic force, isn't it? Okay, so why suddenly you have this centripetal force or the magnetic force? Because this is a moving charge. This is a moving charge. Why you say moving? Because it has velocity. Okay, it is a moving charge. Okay, this is a charge particle. This charge is moving in the magnetic field. So this must be a magnetic field. Magnetic field. Okay, this must be a magnetic field that causes the magnetic force. Okay, but we don't know the direction of magnetic field, so we want to find the direction of magnetic field now. Okay, so we're going to use our right hand rule. Okay, this moving charge in magnetic field that produces the magnetic force. So our right hand rule is let me draw our right hand. Okay, this is our right hand, so this is our finger, this is our palm. Okay, our palm. So all right, this our palm is over here. Yeah. So okay, our right hand. So how to determine the direction? So okay, so the finger, the forefinger shows the velocity, and then the palm shows the magnetic field. Okay, the palm, and then the thumb is the magnetic force. But the thing is, if it is a if it is a positive charge, then if it is a positive charge, then the direction of magnetic force follow the thumb. Understand? If it is a positive charge. But if it is a negative charge, yeah, if it is a negative charge like the previous video, maybe I should okay, all right, okay, never mind. Okay, wait first. So because this is a positive charge, so the direction of magnetic force follow the thumb. Okay, but if this one is a negative ion or negative charge, then the direction of magnetic force is opposite the thumb. It is opposite the thumb. Understand? If it is a negative charge, if negative charge, the force is opposite the thumb. Right now it is a positive charge, so it follow the thumb. This one, yeah. Okay. So I want to copy this. So if right hand rule, so now if last time the previous example, this one, okay, this one is a negative ion, isn't it? It's a negative ion. It's a negative ion. So for this case, we're going to use which one? We're going to use okay. So this is not. We are going to use the opposite the thumb. Understand? So if because this one is a negative ion, so negative charge. The finger still shows the velocity, the palm still the magnetic field, but the magnetic force is opposite the thumb. Understand? Opposite the thumb. So opposite the thumb. Okay. So for this example, now the current example is a positive ion, so the magnetic force follow the thumb. So just the difference, yeah, just that difference. So now I'm going to use this right hand rule to apply in our questions here. I'm going to show you now. Okay, let me draw something on the paper first. Okay, so now I'm going to show you, yeah, this one, yeah. Okay, so you can see here, this is my positive charge moving clockwise. Okay, positive charge moving clockwise, okay, to the right. So So my magnetic force is downward because the center is here. The centripetal force is towards the center of circle. Okay, the centripetal force towards the center of circle. So our centripetal force is provided by the magnetic force. Okay, so our magnetic force is downward. Okay, so now use our right hand rule. Yeah, right hand rule. This is my right hand. Okay, this is my right hand. Again, the finger. Okay, my finger is the velocity. Okay, okay, again, see, my finger is the velocity. My finger is the velocity. My palm is the magnetic field. My palm is the magnetic field, and my thumb is the magnetic force. If it is a positive charge, then it follow the thumb. If it is the negative charge, okay, negative charge is opposite the thumb. Okay, if positive charge, okay, if positive charge, it follow the thumb. If negative charge, it opposite the thumb. Understand? Okay. So, okay, velocity, magnetic field, force, magnetic force. This question is a positive ion. Okay, it's a positive charge. So the magnetic force follow the thumb. Understand? Okay, back to our example here. So okay, this one. So our velocity. Okay, our finger is the velocity. So point in direction of velocity. Okay, and then point in direction of velocity, and then our force is downward. Our magnetic force is downward. So my thumb, because this is a positive charge, you see that this is a positive charge, so it follow the thumb. Follow the thumb. So my thumb should point downward. My thumb should point downward. So velocity to the right, velocity to the right, but the force must be downward. So my thumb should be downward. This way, understand? Like this. Velocity to the right, force should be downward. Okay, force should be downward. So where is my palm pointing? My palm is pointing facing you. Yeah, going out of page. Do you see that? Going out of page. My palm is the magnetic field. My palm is the magnetic field. So my palm is going out of page. My palm is going out of page. Out of page. Okay, velocity to the right, force, magnetic force is a positive charge. So you follow the thumb. Thumb must be pointing downward. Okay, so my palm is the magnetic field. My palm, so it's going out of page. Going out of page. So let me draw out the magnetic field. So it should go out of page. Our magnetic field. This is our magnetic field going out of page. Understand? Our magnetic field should going out of page. So let me draw more of it. Yeah. The dot means going out of page. Okay, dot means going out of page. Understand? This is the direction of magnetic field. Dot means going out of page. Understand? Okay, so that's going back to our slide. All right. Okay. Yeah. So this one, using our right hand rule. Okay. So we found that the magnetic field is actually going out of page. So you have to draw it dot. Yeah, dot. All right. Oops. Yep. What is this? Okay, so this is our magnetic field direction. All right. So so magnetic field is the direction is going out of page. Okay, going out of page. Yeah. Last time the previous example using the negative ion. Negative ion, the magnetic field is going into page. You see that? Because it's a negative charge. Yeah, using our right hand rule, we found that magnetic field is going into the page. But for positive ion, For positive ion, the magnetic field is going out of page. Okay, that's all for this question. Bye.